How do exponents work when finding GCF for variables? Imagine you're trying to find the biggest common piece that fits into all parts of a puzzle. When working with algebraic expressions, especially with variables, exponents are like the sizes of those puzzle pieces. They tell us how many times a variable is multiplied by itself. To find the greatest common factor for variables, we focus on the smallest exponents of the variables that appear in all terms. Here's how it works step by step. First, look at each term in your expression and see which variables are present. For example, if you have one term with x to the power of 3 and another with x to the power of 5, both have the variable. Next, check all the terms to see which variables are common to everyone. Only those variables can be part of your GCF. Now compare the exponents of each common variable. For each variable, find the smallest exponent among all the terms. If one term has x to the power of 3 and another has x to the power of 5, the smallest is 3. That means the GCF for the variable is x to the power of 3. Repeat this process for all common variables. When you write the GCF, include only those variables with their smallest exponents. For example, if you have terms with x to the third and y to the second, and another with x to the fifth and y to the fourth, the GCF is x to the third times y to the second. This ensures the GCF divides evenly into every term. Think of it like taking the smallest building blocks from each term to create a common base. This method is similar to finding the GCF of numbers, where you look at prime factors and pick the smallest powers. For variables, exponents are like those prime factors, guiding you to the smallest powers shared by all terms. When factoring polynomials, you first find the GCF of the coefficients, which are the numbers, by prime factorization. Then, for the variables, you apply the same rule of choosing the smallest exponents. Once you identify the GCF, you can divide each term by it, simplifying the entire expression. This process makes it easier to work with complex polynomials and prepares them for further factoring steps. So, in simple terms, the exponents tell you how many times a variable is multiplied by itself. When finding the GCF for variables, you look for the smallest exponents of the variables that appear in all terms. This approach helps you break down polynomials into simpler parts and makes your algebra work much smoother.